back, everybody. This is Malik, and I've had a couple of requests in the networking class to go into a little bit more detail about the OSI model. So, what I'm going to show here is just the broad spectrum of the OSI model. I'm not going to link it to the TCP/IP model. We'll do that later. But really, what the OSI model is, and why we have it, and what to expect. Like if you're going to take Net Plus, the Net Plus test, and even you'll get some questions in Security Plus on what happens on each layer of the OSI model. So we're gonna break it down layer by layer and what exactly that layer does. So to kind of start this thing off, um, first off, of course, what is the OSI model? Well, it stands for Open System Interconnect. It's a 7-layer structure that helps us see what is broken down when you transmit data from one node to another node. So it separates all network functions into layers, and each layer does specific things. Just so you know, it was defined by the ISO standard 7498-1. It is a standard, um, and a big thing to truly understand, we do call this a protocol stack. So every layer relies on the layer below it and supports the layer above it. So that's why we call it a stack. And that stack runs really in two directions. There is layer 1 to layer 7, but it doesn't always run 1 to 7. Sometimes it runs 7 to 1. The main benefits of why we have the OSI model is so we can understand what happens during data transmission to get the overall picture of networking, how software, hardware, and protocols all work together, and it even helps to when it comes to troubleshooting network issues. All right, so to break this down into just the 7 layers, and then we'll break it down layer by layer. Going from layer 1 to layer 7. First layer is going to be your physical layer. Then we go into our data link layer. Then we have our network layer, our transport layer, our session layer, our presentation layer, and finally our application layer. Now, the way this is written, the physical layer is always layer 1, application being layer 7. Even though the data flows in both directions, sometimes you go application to physical, sometimes you go physical to application, layer 1 is always the physical layer. Now, an easy way to remember your layers, there's tons of mnemonics out there. The one that most people learn is please do not throw sausage pizza away. And you just remember the PDNTSPA. And that's going to help you memorize physical, data link, network, transport, session, presentation, and application. All right, so that's just the names of the 7 layers. But what do these individual layers do? What do they accomplish? Well, let's start up at the top at layer number 7. So kind of picture that you're in email, or you're in a web browser, or whatever. You're in something that requires networking, a program that is bound to a network protocol. So let's just say you're in your web browser. Well, the application layer itself is the interface, what the user sees. Very simple layer. Now, it's big to know that any app that communicates over a network will fall inside of the application layer. Not all applications fall inside the application layer. If the app itself doesn't support network connectivity, well, then it doesn't fit. Um, so any program you have that's a standalone program that doesn't send data packets over the network while you're inside of the app doesn't count. It's not part of the application layer. You have to leave that app. So let's say Office 2003. Well, Office 2003, if I wanted to send a file up to SharePoint and I still had 2003, I would have to save the file on my desktop and then go into SharePoint and then upload the file. Well, in newer versions of Excel or Word or whatever, I can upload directly to SharePoint. So new versions of Office actually fit in the application layer because they do support network connectivity inside the app itself, while older versions did not. So anything that communicates over a network, of course, web browsers, email, FTP, DNS, POP, DHCP, NTP, whatever you can think of, fits inside the application layer. Okay. This is the overall platform where we send and receive data. Email and web browsing, of course, being the biggest two that most people think of. It's a very simple layer to understand. Okay. This is your file transfers. You're printing, sending emails, sending messages, of course, going over the internet, browsing your network. Okay. Now to move to the presentation layer. This is what prepares the data to be transmitted. It will mark that application data with a format code. Yeah, this is an MP3, this is a JPEG, this is a text file, this is a Word doc, this is this. Now yes, programs do this all the time, but when you're in a networking program, this is what marks the code inside of the packets that's going to be transmitted. So the receiving machine knows what type of file it is. It can also compress the data and can sometimes encapsulate, although that's usually done much later. Encapsulation works better at a lower level than at level 6, but it always compresses the data. So it allows the application layer, when you're coming back up, to read and understand the message. Okay, the session layer. This is your connection, and it makes sense by the name. It strictly deals with connections. This is what establishes the connection, maintains the connection, and will terminate the connection after all data has been transmitted. It also does a ton of other stuff. It syncs the data flow, so it's not pushed too slow or too fast. Of course, during the beginning of the session, it will negotiate any sort of parameters that need to happen for the connection to be established. It sends acknowledgments if we need it to send acknowledgments of receipt of data. And in the absence of an acknowledgment, it will retransmit the data. All dealt on the session layer. The transport layer, again, if we go by the name, we can pretty much see what it's going to do. This is your end-to-end communication. So if we're going down from the top down, we have now established a session. We're in our app. Our app has been, our data has been formatted. We have established a session, and now the transport layer is our end-to-end communications. This is where we set up the transport itself. Now, depending on how the application is written, we can either do this connection-oriented, TCP, or we can do this connectionless, which is UDP. And this is one that, some people get mixed up. TCP requires a three-way handshake. That's why they call it connection-oriented. When I want to talk to your machine, or when I'm transmitting to you, when I want to talk to you, I'm going to send you a packet that's going to ask you, hey, can we synchronize, called a send packet, over port 21. Choose the FTP port. If port 21 is open on your machine and you allow it, you're going to send me back a packet that acknowledges the packet I sent you, and that sends this, so that's an ACK, and a SYN too that says, okay, yeah, we can synchronize. It's called a SYN-ACK. I am then going to turn right back around and acknowledge yours, in which case we establish a session. When I send you packets over TCP, you are going to acknowledge receipt of that packet. That's what TCP does. That's why they call it connection-oriented. UDP is connectionless. There is no three-way handshake. And I'm going to send the packet out and hope that you get it. So the way I explain it in class is UDP is very similar to you going to your mailbox with a letter and sending it out, regular mail. They're probably going to get it, but if they don't, it's not like you're going to get a response back that your letter got lost. That's UDP. Now, if I go and send it certified and say, okay, when they get this letter, let me know that they got it because they have to sign for it, and then let me know that they signed for it, well, now I have proof that they got it. That's TCP. So that's done on the transport layer. Of course, when TCP is used, we throw in sequence numbers and acknowledgments and flows, control flows such as windowing. It also allows for multiplexing, which is where we can have multiple applications receiving and sending data at the same time. And the biggest thing here, segmentation. When you send a 1 gig file, you do not send it one file that's 1 gig in size. You break that file into smaller files that can be transmitted. Transport is what breaks it into the smaller files. Okay, the network layer. This is where we get, well, we'll get a set of headers from here, but we get our IP address, we define the IP address, and we find the routes of those IP addresses so it can reach its intended destination. Now, routers use the packets created by this layer. Routers work at this layer. And there's routing protocols, RIP, OSPF, EIGRP. There's going to be another video on there understanding the difference between the three main ones, RIP and RIP v2, OSPF and EIGRP. We'll have a completely different video on that and understand that because that's a big thing in NetPlus. But routers work at the network layer, at layer 3. Now layer 2, the data link layer, allows devices to access the network. It also sets up error detection, not error correction, but error detection. The MAC address is added here. So network, we're dealing with the IP. Data link, we're dealing with the MAC. This is also where we deal with encapsulation. Instead of dealing with it all the way up at the top in the presentation like we talked earlier, it's much better to do it at a lower level. NICs work here, switches work here, bridges work here. And the very last layer is the physical layer. This is your connectors. This is your cables. This is your interfacing. This includes wireless too, so this is air. This is where we take the frame that's built in the data link layer and we break it down into bits. Because the bits are actually what's loaded on the media, on the cables. And it goes out to transmission. So that's the OSI model going down. So what happens when two machines want to talk to each other? Node 1 wants to talk to Node 2. We'll say Node 1 is going to a website on Node 2. So Node 1 is going to work from the application down to the physical. So Node 1 wants to send some data. We'll say it's through a web portal. This could be anything. So, of course, the application itself is at the application layer. The application layer is going to send that data to the presentation layer. The presentation layer is going to format it, set it up into the type of data that it is, and send it to the session layer. The session layer is going to initiate a connection with Node 2 and then forward it down to the transport layer. The transport layer is going to take this file that you want to send, however big it is, and break it down into smaller segments. It's going to add headers and the control data inside of it. Pass that down to the network layer. Those separate segments at the network layer is going to add its own header with the IP address, and now it truly turns into a packet at the network layer. Okay, that sends it down to the data link layer. The data link layer attaches its own header and footer and converts it to a frame. Passes it down to the physical layer, which is converted to signals. They're converted to bits. Those bits are loaded onto the media and it's sent across the network. When it gets to node number 2, the steps are reversed. The physical layer gets the signals, converts those into frames, and forwards it up to the data link layer. Now, some different things happen here. I didn't go into it because, this could be an entire book. But the data link layer is going to do some checks. It's going to make sure that nothing has been tampered with, nothing looks wrong. If all frames are correct, it removes the header and footer that were put on from the data link layer from node 1. There's multiple headers and footers in this thing. It only can remove the one added on by its own layer. So it removes the header and the footer from the frame at the data link layer. and then passes it up to the network layer. The network layer will check it and will remove its own header and footer, and then send it up to the transport layer. The transport layer is going to verify that all the segments are there. It is going to remove the header and the footers, and then reassemble the segments back into the data. Because remember, this is where it tore it apart. This is where it's going to put it back together again. If you've ever noticed on a download, when you're downloading a file, it never picks up that file extension or never picks up that file icon until all the data has been downloaded, because it hasn't been pulled back together yet. You're only getting bits of it. So it doesn't know what it is yet. In fact, it doesn't know what it is even after it's assembled. The session layer, of course, keeps track of the open connections between node 1 and node 2. And all the data is sent up to the presentation layer. The presentation layer forms that data back into the extension that it was before it was torn apart. So back into an MP3, or back into a JPEG, or back into an ISO, or whatever type of data, in which case it's sent up to the application layer, finds the program that it needs to open it, and the data opens. So that's the step every time you work in a program that has network connectivity. Everything you send goes through these steps from application to physical, and when it gets to the other end, it goes physical to application. So what this is going to really spin off from here, and typically the type of questions you see on the Net Plus test and things like that, is what happens on this layer? What happens on this layer? But I'll have another video out shortly to where we connect the TCP IP model with the OSI model. Not as many layers, because they've merged some layers. But we'll go over that and how that kind of fits in on what happens with that, as well as breaking down routing protocols, because routing protocols are a very large thing, especially when you get into Cisco or CCNA. So that's what happens when data is transmitted or data is received. Of course, we can go into a ton more detail on windowing and sliding windows and what happens with that, but this is the OSI model in general and how the OSI model works. All right, well, very cool. So I hope that helped you understand some of it and help you memorize the steps. You're definitely going to have some questions on the Net Plus test about it, and you may even see them in other tests. But you need to understand what is done at every single layer of the OSI model, and typical protocols that work on each layer. I didn't break this down into that, but once you know what each layer does, you can figure out what protocol works on it. All right, so be on the lookout for a couple other videos that's going to spin off of this one, the routing protocols video and the TCP IP video that links in with the OSI model. And then there's a couple of more that I want to put up that deals with networking. So until then, if you like the channel, please hit that subscribe button, and let me know in the comments if there's any particular questions you have or any particular videos you want to see. I'd be more than happy to get those up and posted for you. All right. Well, until next time then. This is Malik, and I'm out.